In this video, I'm going to show some examples of word problems that involve conversions in the metric system. Question 1 says a scientist charted the growth of a poplar tree and a willow tree. In 1 year, the poplar tree's height increased by 297 centimeters, and the willow tree's height increased by 2.97 meters. In that year, which tree's height increased more? I can't compare these two measurements directly yet because I have different units. I have centimeters here and meters here. So I either need to convert 297 centimeters to meters, or I need to convert 2 and 97 hundredths meters to centimeters. Doesn't matter which one, but they have to be the same unit. If I were to convert 297 centimeters to meters, it takes 100 centimeters to make a meter. So I just need to find out how many groups of 100 that I can make here. And because we are dividing by a power of 10, I'm going to shift the digits to the right, which means the decimal will go to the left. And we'll have 2.97 meters, which is the same as the willow tree's height, the amount that it increased. So both trees increased the same amount. Question 2 says on a track, Ananda ran 2 4/10 kilometers before stopping for a drink. BM ran 2,400 meters before stopping for a drink. Who ran farther before stopping for a drink, or do they run the same distance? Just like before, I have two different units, kilometers and meters, so I'm going to have to convert the either kilometers to meters or meters to kilometers before I can compare. I'm going to change 2 4/10 kilometers to meters. Inside every kilometer is 1,000 meters. So what I'm doing is multiplying this number by 1,000. And when I multiply by a power of 10, I'm going to shift the digits to the left, which means the decimal point will appear to shift to the right. 3 powers of 10, 2 placeholders there, and I have 2,400 meters. And 2,400 meters equals 2,400 meters, so they both ran the same distance. Question 3 says Brianna is reading food labels. She discovers that a can of chicken soup contains 835 milligrams of soda. She also notices that the same size can of tomato soup contains 825 thousandths gram of sodium. Which soup contains more sodium? Just like before, I have different units. I'm going to change 835 milligrams to grams. It takes 1,000 milligrams to make 1 gram. So I need to divide this by 1,000 to find out how many grams I have. And I won't even have 1 full gram. I have 835 out of 1,000 that it takes to make a full gram. So this is equal to 0 and 835 thousandths. 835 thousandths is greater than 825 thousandths, which is the tomato soup, so the chicken soup has more sodium in it. And our last question says Ikuko is learning to read and understand food labels. She discovers that a can of chicken soup contains 620 milligrams of sodium. She also notices that the same size can of tomato soup contains 0.6 grams of sodium. Which soup contains more sodium, or do they contain the same amount? This is the same as our previous one, except with different numbers. This time I think I'm going to convert the opposite direction, so I'm going to use a 0.6 grams and change that to milligrams. There are 1,000 milligrams in every gram, so I want to multiply this by 1,000 to find out how many milligrams are in 0.6 of a gram. I'm going to go ahead and just do this with fractions. I can simplify, and I get 600 milligrams. 600 milligrams is less than the 620 milligrams. So the soup that contains more in this problem is the chicken soup.